Today we'll be making a Minesweeper clone with Python and Pygame. First, let's make a game class. This will represent the user interface. We can take in a board that we'll pass in later and set the board to be board. And then to run it, let's make a function that initializes Pygame. Grabs the screen from Pygame, pass in the size, which we can pass in to the constructor. So that will be the screen size. Let's make this screen size. And then this will be self screen size. We'll set up the main loop. So while running this true, we'll listen for events by grabbing events from Pygame. If it's the quit event, then we'll break out of this loop. And then we will update the screen. And then quit once we're out of this loop. So in main, let's import game, make a new game. The board, we'll start with none. Well, actually just board. And then pass in the size, screen size. You can make it 800 by 800, and then run game. So if I run main, it should give me a black screen. Okay, so that's working. Next thing we need to do is to make the board class that we'll pass into the game. We'll pass into the constructor the board size, so the rows and number of rows and columns. So for example, if I go into a 9 by 9, it'll have 9 rows and 9 columns, so that will be the size. So set the size to be that, and then we can make a 2D array or a list of list to represent the board. So we can call a method setBoard and define it here. So we can make a list to be the board and then iterate through the rows and columns. So in the range of our size, so number of rows is size of the first index, and column is at the height at the first here. In the outer loop, we'll make a new list row. In the inner loop, we'll add to the row a piece, which will represent an individual piece on the Minesweeper board. We can set this as none for now. And then at the end of the outer loop, we'll add the row list onto the board. So we can, in our run, we can draw the board. So we're going to make a function that draws the board. And we can just, for now, draw an empty block. So first we have to load up the images, which I've just downloaded some textures. So in our game class, we should probably make a function to load up the images. So load images. So what we want to do is make a new dictionary called images that maps the name of the image, so whatever's before the .png extension, and an image object, which we can grab from Pygame. So we will walk through the directory images. We'll have to import OS. So for file in os.list directory, and we're in the images directory, we're going to grab the image using Pygame's image. So we'll call image.load, and which takes in a file name. So we'll load images / the file name, and we'll do this only if the file name doesn't end with .png. Then we don't want to add this image because it's not actually an image. But anyways, then we add the file name. We'll split by periods, so everything before the .png will be at the 0th index. We'll set that equal to our image object. And we'll also have to transform the image to be the size that we want with respect to the pixels. So we can do that with transform. So we'll have to transform by scaling to a new resolution. And we scale our surface onto a specific width and height, and it returns a surface. So transform scale our image onto a piece size, and we'll have to grab the piece size from here. So our piece size will just be size, our screen size, divided by the size of our board. So the height of our board divided by the number of rows, and the width of our board divided by the number of columns. So start with the width. So this is the width divided by number of columns. We'll have to define a getSize method. Number of columns, and number of, or this is the pixels in the y dimension divided by number of rows, and it has to be integer division. Back in our board class, we should probably define a function to get our size. So return our size back here. Now we can transform our image, grab the piece size, and in our draw, we will start with the top left position from which we are drawing to be 0, 0. Then for row in the range of the board's number of rows, and for column in the range number of columns, we will draw probably be in the surface image display. Oh, surface. We will blit our image on. We'll blit onto our. We'll blit the image onto our screen. So screen will blit the image onto the top left. So the dest argument is coordinates representing the top left of the blit. Top left. And our image will just be, we can start off with our images dictionary indexed at empty block. And then after each iteration in the inner loop, we'll increment the top left coordinate to be whatever the x coordinate is plus the width of our piece, and the y coordinate will stay the same. Each iteration in the outer loop will make the x coordinate be 0. Whoops. And the y coordinate be whatever the y coordinate was plus the height of the piece size. Okay. So if we run this, it should draw an empty, or it should draw this thing. None type has no, okay, so we need to initialize the board. So from import the board. We can start off with a 9x9 board. Game has no attribute images. Okay, so it's because we've loaded the images. Oh, we gotta call it. But yeah, we have to call the method. Pygame has no attribute image. Did I spell something wrong? Oh, it's lowercase. Okay. Game has no attribute screen. Okay, this has to be self. Alright, so looks like we've successfully blitted the empty block onto our screen. Now time to add some logic to our game. So we're appending a piece onto each position. So we should make a piece class to represent each individual piece. So a piece will take in an argument that's a Boolean, has bomb. So this will be whether or not the piece is a bomb. And initially, all pieces are not clicked. All pieces are not flagged. And let's write some accessor methods. Okay, so now instead of adding none onto each position, we'll add a piece has bomb, and has bomb we can set later. Should probably import piece, and then has bomb can be, we can implement this with a probability that's passed in to our board. So this will be the probability that each piece is a bomb. And has bomb will just be if a random float is less than this probability, has bomb will be true. So let's import random. And in our main, our board will not just have a size, but also probability. And let's set probability to be maybe 50% to start. So we'll modify how our game draws the board to test if our functionality is working. So image, we'll make a method to get the image based on the piece, and we'll get the piece from the board. We'll get that by passing in the index. So let's get a piece from the index. So return from our 2D array are indexed at the row and the column. Oops, so set up self. And so getImage, we'll make a new method. String will just be none, and we'll return whatever string we set based on the information we get from the piece. That will influence what the string is, and then that will index into the dictionary. So let's just test if our bombs are working. So string will just be get has bomb. That has a bomb. We'll make it a unclicked bomb. If it has a bomb. Otherwise, we'll make it empty block. So now it should be about half filled with unclicked bombs, which looks like this. If we run it, prob is not defined. Okay. Board has no attribute prob. We have to put this before this. Has bomb is not defined. Oh, because this is a self. Okay, so the board is about half filled with bombs. Now, the next step is to add functionality so that each piece can detect the number of bombs around itself. So to do that, we can make a function, getNumAround, that returns num around. But this relies on the neighbors of each piece, which is the 9 pieces around each piece, or less if it's on a corner or edge. So when we set the board, we should add a list of neighbors to each piece. So after we set the board, we can make a method set neighbors. So what this does is it's similar to setBoard. We iterate through the rows and columns. And we get the piece. At the index. And then we need to add a list of neighbors to the piece. So piece set neighbors. And we can make a method that adds neighbors, a list of neighbors of the piece of interest. So get list of neighbors. Pass in the piece. Get list of neighbors. Should probably be index, because that's what it depends on. Whoops. Row and column is what we pass in. And neighbors equals a list. And then for the row and the range over first of the current row -1. So we want to start at the row less than what we passed in and go n before the row +2. Same thing with the columns. I want to start at the column before the position of interest and before the column +2. But we don't always want to pass in whatever piece is at the row and column. If the piece that we've landed on, indexed at this position, is what we passed in, we don't want to add into it because a piece is not its own neighbor. Also, we want to be careful about out of bounds errors, so let's check for those. So out of bounds, we'll check if row is less than 0 or row greater than or equal to our number of rows. Whoops. Or something with columns. Or if it's the same, row is equal to the passed in row, and same thing for the columns. So if the same or out of bounds, we want to just continue don't add to the list of neighbors. Otherwise, we'll append, we'll get the piece at the position that we've iterated onto, and then return our list of neighbors. Okay, and then, so we've returned a list of neighbors, and we're going to add that list onto the piece. We'll probably have to add a method, set neighbors, and we'll set a list of neighbors to be whatever was passed in. Num around we can set also in this method. Set num around. This is only called by that method. So num around equals 0. So this counts the number of bombs around the piece. So iterate through the list of neighbors if that neighbor has a bomb. What we'll do is increment num around, and then set, we can just do this, and yeah, so that will return what we'll set here. So to test if this is working, let's modify again how we are setting the image. So string will be unclicked bomb if it has a bomb. Otherwise, we can do the number of mines around, and we'll change that to a string. And so that will get either, it'll get the number of mines around. So if it's 0, it'll be this. If it's like 4 mines around that piece, it'll show up like this. So hopefully that works. Self is not defined. Okay, it looks like our neighbors functionality is working. So our next step is to actually make the image system work like the game. So let's get rid of this. So if our piece is clicked, then we'll do stuff, but it's not clicked. Otherwise, let's just set it for now to be empty block. So should all be empty blocks. Alright, so now let's add functionality for making the board be able to be clicked. So we'll listen for events here. If the event is mouse button down, so whenever the user clicks, we'll handle the click. We'll make a function for that at the position of the click. So that's get position, I think. Get pos. Okay, in our handle click method, convert the position into an index using this. So we'll grab the X position, or probably the Y position first, of the Y position of the mouse click divided by the piece size. That will yield the index on the board. So integer division by the number of pixels in the Y direction. So that's 1. And same idea for the X dimension. So that's the number of piece size indexed at 0 is the width of the piece, and that's the X position. So let's just test if this is working. We'll print out the index, and what's printed should be 0, 0 here, and here will be something like 6, 5 or 6, 4. Yeah, and this will be 8, 8. Okay, so that's working. Now we can pass this information into the board. We'll let the board handle the click now at the index. So handle click at the index. Actually, we'll make it click a piece, and then we'll grab the piece from the board, from the index, and then click the piece. Okay, so we also need to add some functionality for flagging. So in our listener, let's grab whether or not it was a right click. So we'll make right clicking represent flagging. So we can use this getPressed method, and we'll grab the second index to get button 3, which is the right click button. getPressed at index 2. Pass in right click, and this will take in right click, which is a Boolean value. Handle click, right click. So this, if it is a right click, it will be meaning that we mean to flag the piece. So we're not going to do anything if it's already clicked, or if we're not flagging and it's flagged, because you can't click a piece that's flagged. You can only toggle the flag. So if I flag this, I can't click on it. I can unflag it though. Okay. So yeah, we've returned from there if that's happened. And we can't click on a piece if it's already been clicked. So if we're flagging it, then toggle flag, and return. So let's see, toggle flag, it's pretty easy. We'll just set flag to be whatever it wasn't. Is it flagged? Yeah, flagged. Let's test if that's working so far. piece has no attribute toggle flag. Oh, toggle flag. Flag is not defined. Self.flag. Okay, no errors, but we gotta make this be reflected in our image. So it's clicked. Otherwise, string is empty block if, actually we'll just do string equals flag if it's flagged, otherwise empty block. Alright, so I'm right clicking and then a flag is appearing and it's getting toggled. Now let's add left click functionality. So it's not a flag, or we're not flagging. So what we'll do is set, we'll just do click, and click will make self dot, we'll make clicked equal true. And we'll check if we've clicked on a bomb here. So if it has a bomb, then we can just say we've lost. We can set that value up here, initialize that to be false because we haven't lost yet, and then return. Otherwise, we can keep track of whether or not we've won or not. So set that to be false also. Let's put this before, we set the board. And we can set a variable num clicked and num non-bombs. So once the number of bomb, we don't need self.one. Once the number of non-bomb pieces equals the number of pieces we've clicked, we've won. So let's get our accessors, get if we've won or not, return if the number of non-bomb pieces equals the number of things we've clicked. And same idea for lost. Well, not really. That just returns the lost variable, which we can check once here. So if we've clicked on a non-bomb, this won't have returned. And num clicked will be incremented. And we can set the number of non-bomb pieces in our set board. If it doesn't have a bomb, then number of non-bombs will be incremented. Okay, last step is in Minesweeper, when we click on a piece that doesn't have any pieces or any bombs around, it recursively clicks on all its neighboring pieces, and then that process, since it's recursive, does the same thing, clicks on its non-bomb neighbors. So that just happened here. To implement this, we can do for if the piece get num around, if it's not 0, we can return. Otherwise, for neighbor in the piece, get the list of neighbors. Whoops. Probably just get neighbors. And we need to grab that list. So neighbors. We want to return our list of neighbors from here. Okay. So we want to, if the neighbor doesn't have a bomb, we're going to, oops, not neighbors, neighbor dot, we're going to click on the neighbor. Actually no, we're going to handle a click. We'll pass in the piece, which is just the neighbor, and we're not flagging it. So set that to be false. If it doesn't have a neighbor, or it doesn't have a bomb, and it's not clicked, then we'll click on it. So let's test if that's working by finalizing our getImage function. If it's clicked, then we will, if it has a bomb, it'll just be bomb at clicked. If it has a bomb. Otherwise, it will just be number of mines around, cast as a string. Otherwise, it's flag if it's flagged. If it's not flagged, then it's an empty block. Let's test if that's working. Num non-bombs reference before assignment. Did I spell something wrong? Oh, self. Okay, so if we click on something, I passed in the method. We have to call it. So, whoops, bomb at clicked block is what I meant. So if I clicked on a mine, it'll be red. If I clicked on a non-mine, it'll show, oh, there's a lot of mines. It'll show the number of mines around. So it's working. There are 5 mines here. This is 5. There are 4 mines around here. This is 4. And it's flagging right. Okay. Let's test if the recursive clicking is working. We'll have to make the probability of a bomb be 0.1 to test that. Okay, it looks like it's working. Yeah. And then we can flag. Okay. Last thing we need to do is to test if our board has won or lost. And we've already got the functionality for that. We just need to handle that in the game. So when we do the handle click, if we have lost, don't do anything, just return. So if we've lost, then don't let us click. Hopefully that'll work. If I click on a mine here, it won't, oh, okay. It's letting us click still. Get lost. Oh, I'm not returning. Okay, now I clicked on a mine. It's not letting me click anywhere. That's working. Now, if we've won, then what we need to do is to set running equal to false because the game is over. I want to play this sound effect, so I will use mixer.sound. Pass in the file win.wav. Sound will play, then we'll sleep for 3 seconds to allow the sound effect to play. So from sleep we'll import, from time import sleep, and that will play running equals false. So if I win this, oh shoot, let's try that again. If I win this game, it will hopefully play a sound effect. Okay, I think something went wrong because I didn't click those top two. Oh, no, they were both bombs. Okay, so that worked. Alright, and I think that's about it. We can make the size of the board be something like 20 by 20. Actually, we'll do 20 rows and 50 columns. Make the screen size 800 by 1400. This will be a bigger board. Oh wait, probably should be the other way around. There we go. It's kind of not really square. 1700. Okay, that's a bit better. Oh, I lost right away. Okay. Yeah, so the game works, and you can change the size and the probability that there will be a bomb. And yeah, there you go. That's Minesweeper.